Welcome to video number 6 of the Math 8-9 Honors course at OKM Secondary. For the topic from section 1.3 of the Math Makes Sense 9 textbook, surface area of objects made from right rectangular prisms. Here we have 4 unit cubes making up an object. To access an online web book, which I'm sure you're already familiar with, but to access not only the book but also the manipulatives, we click on SD23 login, click on the book of your choice, in this case Math Makes Sense 9. It did not prompt me to enter a username or password. I had already been logged into the site. As far as the text goes, the student book is the one that we want, not the prep and practice book. At the very top, we can click on Media, Try It Virtual Manipulatives, Lesson 1.3 Surface Area of Objects made from right rectangular prisms, and a green button here that says Try It. So that object can be made with this program. Click on the arrow. You are now enabled to make that object by clicking on each of the spaces provided. And there is the object that we made using the program in our web book. This is really neat because it shows us the top, left, front, right, bottom, and back views. You can play around with this program if you want to add more cubes on top, or when I press on the eraser tab, we can take away blocks. There are 2 strategies for determining the surface area of the object that we saw in number 1. Strategy number 1 is to count all the faces, then subtract the overlap between each cube. Each cube has 6 faces. There are 4 cubes. So 6 faces times 4 cubes means that there are 24 faces in total. We also need to consider the overlap. Looking at our diagram, we see that there is 1 overlap in here, so 2 faces are being covered between the green and the yellow. Another overlap between the green and the red, and then an overlap in behind between the blue and the green. So 3 overlaps in total. Two faces are covered with each overlap, meaning that we have 6 faces that are covered because of overlap. This means that the total surface area will be found by subtracting 6 from 24, and we end up with 18. Since we are told that each face has an area of 1 square centimeter, we say that the total surface area of this object is 18 square centimeters. A second strategy would be to show all of the views and then count up each of the faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 faces are exposed. So the surface area of this shape, 18 centimeters squared. When an object, such as the object seen in number 1 above, is made up or composed of other objects, it is called a composite object. For instance, we have a composite object in number 4, a warehouse measuring 60 by 30 by 20, with an office attached to one wall of the warehouse, and that office is measuring 20 by 20 by 10. We need to determine the total surface area of the building. With composite objects, such as in number 1, we include the bottom faces as a part of the overall surface area, total surface area. But when we have examples such as number 4 with buildings, we do not include the bottom as a part of the total surface area. So the building's bottom is not included. Let's start with the warehouse. The area of the roof, length times width, 60 by 30, 800 square meters. The area of the right and left walls are 20 by 30, and there are 2 of these. 600 times 2 is 1200 square meters. Area of the front and back, 20 by 60. 1200 by 2, 2400 square meters. The office, area of the roof, length by width, so 20 by 20, which is 400 square meters. Area of the right, the left, and the front, all same dimensions. These are all 20 by 10s. 3 of these faces. It's 200 by 3, 600 square meters. There is overlap. It's the front of the warehouse. So we didn't include the back of the office in our office calculations, and that's a good thing. It's not exposed. But the front of the warehouse is being covered. The front was included in the area of the front and back, so we need to subtract that little portion that's being covered in the overlap in behind the office. The area being covered is a 20 by 10, so 200 square meters. The total surface area is 1800 plus 1200 plus 2400 plus 400 plus 600. Subtract the 200 for the overlap, and we get 6,200 square meters. Therefore, the surface area of the building is 6,200 square meters. We have a contractor being quoted to paint the outside of the building at a rate of $2.50 for every square meter. How much would it cost to paint the building? Keep in mind that there are parts of the building that will not be painted. The roofs on each building, so on the office and on the warehouse, no paint on the roofs. The office door, we're being told, has 2 square meter area, will not be painted. 3 loading doors, each measuring 10 by 15 meters, and 4 windows on the office, each with an area of 1 square meter. So, what is not painted? Well, the area of the roofs, we already know from part A, are 1,800 and 400 square meters, so for a total of 2,200 square meters. The area of the office door, we're told, is 2 square meters. The loading doors, LD for loading doors, these are 10 by 15. We're told that there are 3 of them for a total of 450 square meters. And the windows, area of the windows, they're each 1 square meter. We have 4 of them, 4 square meters in total. So, what will be painted? Surface area of the painted areas will be 6,200 square meters, calculated in part A. Subtract 2,200, subtract 2, subtract 450, subtract 4. 3,544 square meters will be painted. Finally, the cost. $3,544 multiplied by $2.50 per square meter for a total of $8,860. Therefore, it would cost $8,860 to paint this building. That brings us to the conclusion of video number 6. You may now proceed to your assignment. Thank you.